So how many cards are in a deck of cards? I'm not talking about jokers, because when you go to Vegas, when you get old enough and you gamble, jokers are not included in the deck. That's not an actual card, all right? So, nope. So how many cards are in a deck excluding jokers? 52. If you count the jokers, it's 56, but we don't ever count them. So have y'all, like, when y'all were little, my brother used to do this to me. He thought it was the funniest thing when really it was just really corny. Somebody took a deck of cards and like threw them at you and said 52 card pickup. Yes, not funny at all. My little brother used to stay doing that. And I was like, I'm not picking those up. Okay. 52 cards in the deck. How many different symbols are there? Good. Let's talk about the different symbols really quick. Okay, clubs. What do the clubs look like? The clovers. Very good. I'm going to try to draw. Y'all know they said, oh, Lord. There you go. There's a clover.
Spade.
Spades. Good. So a spade looks like an upside down heart with a little trunk, right? Okay.
Hearts.
You actually have hearts. Good. And then you have
Diamonds.
Good. So there's 4 different symbols. So y'all listen, since there's 4 different symbols and there's 52 cards total, how many of each symbol are there? Good. How'd you get 13?
52 divided by 4.
Divided by 4. Very good. So there's 13 of each of these. So the reason I'm telling y'all this, on your test, there are going to be card questions. And if you mess up, like how many there are of each symbol or how many of each type or how many total, your probability is going to be wrong. Okay. You got to know a deck of cards for math 2 and again for math 4. They do lots of probability. All right. How many different cards are there?
13.
Good. Y'all just said 13. So let's talk about it. You got a 2, a 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. So there are 13 cards. How many are there of each card? So like how many aces, how many kings? 4. Good. Because there's 1 of each symbol. So like you'll have a king of clubs, king of spades, king of hearts, king of diamonds. Same thing for all types. And then last but not least, how many cards in the deck are red? Good.
26.
Good. Good, Carter. Half of them, 26, which means the other half are black. Good. It's okay. Half are red, half are black. Do you guys remember from like playing with cards when you were a kid? I'm hoping y'all play with cards, even if it was on your iPad playing solitaire or war or something. Do you remember which symbols are red and which ones are black?
Clubs and spades are black, hearts and diamonds are red.
Very good. Clubs and spades are black. So let me draw y'all a little arrow. Hearts and diamonds are red. So you need to take this sheet. We're going to set up our notebooks in a minute. But you need to take this sheet and make sure it gets put in your notebook later, okay? Any questions on the warm-up? So we did finish up Unit 3. Page 29 is where you should have put your test review. And today we're starting Unit 4A, which is on basic probability. And then today we're going to start on page 30. So this will go on one side of page 30 and your actual notes will go on the other side. But today we're going to be talking about intro to probabilities. So a lot of what we're doing today is probably review. I'm so glad y'all joined Zoom because as long as you're participating during these probability experiments, you're going to get extra credit. So I don't do a whole lot with basic probability notes because y'all are honors kids, which means you were good students in middle school, which means you usually know a lot of this, okay? So I like to go over basic probability with you guys actually doing like probability experiments. So my people on Zoom, I have coins and dice and cards. Y'all are gonna be doing it with me, and I'm gonna turn them loose on experiments together. So that's what we're gonna start with, and then we'll roll into notes. Sound good? All right, so what we're about to do to help us take these basic probability notes, Chris, you listening? My boy flipping his coin. He said he knew how to flip it the same way every time. Oh, okay. All right. You need to go to Vegas then. So we're going to run some probability experiments. You guys are doing them on your own. Y'all are going to do them with me just because I'm not sure how many of you have a coin or a dice at home. If you have one and you want to do it on your own, that's fine too. Okay. So we're going to start with coins because that's the least amount of outcomes, right? There's only 2 different outcomes. Then we're going to move to dice, which has how many outcomes? 6. And then we're going to move to cards. Sound good? Yes. It won't. Yeah, it won't. Gravity pulls it down on one side. All right. So y'all listen, because I'm going to stop recording in a second. What we're going to do, I'm going to put a penny underneath here. I hope y'all are listening too, because these are your directions. You are going to flip your coin 10 times and record each outcome. Did everybody hear me say that? So if the first time I get a heads, I'm going to write heads. The second time, if I get tails, I'm going to write tails. But you need to make sure you write it for all 10. Okay? All right. When you're ready, go ahead and start flipping your coin. All right, my people at home. So from this data, people in class, this is for you as well. Once you get your 10 outcomes, I want you to find the probability that you flip the heads and the probability that you flip the tails. So from your experiment, how many times did you flip heads? How many times did you flip tails? All right, so with me and the people at home, our probability that we flipped a heads occurred 6 times out of how many? Out of 10. So listen, when you are writing probabilities, it is a ratio. It's the number of times you did it out of the total number of outcomes. We're going to write that in a minute. But we got 6 out of 10 for ours. How else could I have written this? 60% or 6 to 10, or you're missing one.
As a decimal.
A decimal. Good, Carter. So 0.6. 6/10. Then my people at home. Oh, hold up. I like that. What did you say? What did you just say? He said you could have also written 3/5 or 3 to 5. Because that would be what 6/10 is reduced, correct? That was good, Jaden. Extra credit. Good job, bud. How many times did we flip a tails, my people at home?
4.
4 out of 10. And if it's okay with y'all, I'm going to go ahead and reduce that to 2/5. You probably will see it written as fractions or decimals, not as percentages. Now, I want to talk to my people in class real quick, so I'm going to pause the recording. Y'all listen next time. So this is what I want us to talk about. What theoretically is the probability of flipping a coin? 50-50. Each one is 50%. How many of us flipped a perfect 50%? That's very, okay, good. They're showing their hands. They're raising their hands. It's just 2 of them out of 10. What's that probability? And we don't have 10 people. We have 8. I can't count. What's 2 out of 8? 1/4, which is 25%. Very good. So a quarter of them flipped the actual 50-50. So here's my question. Why do y'all think most of us don't flip 50-50? I like what you said. What did you say? That's not what I thought you said. He said something about being different. What is different when you're flipping that coin? I'm not comparing you to other people. That's not what I'm saying. Okay, I like what he said. Chris said, well, first of all, it would depend what side you started on. My people at home, was Miss Poole a good coin flipper? No. No, trash. Look, somebody called me out. They said, nope. So every time I did it, am I flipping it the exact same way? No. And it's not because I'm like bad. You could be a great coin flipper. You'd have to hit it at the exact speed and the exact same direction, starting on the exact same side every single time for it to end up perfect. It's very, very close to impossible because we are what? Human, and humans make errors. We're not computers. That boy said, I'm a different breed. We're not computers. We're not robots. So we're not going to be able to do it the exact same way every single time. So does everybody understand the difference in our experiment probability and the theoretical probability that we should get? That's a big topic in math too. Y'all are good? All right, so the second experiment. Your dice. Everybody paying attention. You are going to roll your dice 12 times and record your findings, okay? So roll your dice 12 times, record your findings. People at home, are y'all with me?
Yes, ma'am.
Once you have your 12 experimental probability outcomes, you're going to find the following. So I want you to find the probability that you rolled a 3, the probability that you rolled a 1, the probability that you rolled an odd, and the probability that you rolled a number smaller than 5. Okay, probability of rolling a 3. I only rolled it once out of 12 outcomes. What about you guys? 4. Okay. They're saying 4 or 3. That's really good. I did hear a couple twos. We'll talk about that in a second. Probability of rolling a 1. I rolled it 3 times, me and my people at home, out of 12. Okay, twice is good. We'll talk about that in a minute. Really? Wow. All right, probability of rolling an odd number. So 1s are odd, a 5 is odd, so that's 3. Those are both odd, so that's 5. 6, 7. So I rolled an odd 7 out of 12 times. You did 8. Okay, if you did 8 out of 12, what does that reduce to? Come on. 2 out of 3. You were right. Very good. If you did 9 out of 12, what would that reduce to? 3/4. Very good. I'm just making sure y'all know how to reduce fractions because that's how you'll see it. And then for D, a number less than 5. Make sure you know your inequality symbols. I rolled a number less than 5. 1, 2, 3, 4, 5, 6, 7, 8 out of 12 times. And if you divide both of those by 4, that would be 2/3. Wow. Okay. So you roll high numbers. That's good. So everybody listen. I hope they're with me. Theoretically, since we did this 12 times, how many times theoretically should I have rolled each number? Twice. Because good, Carter. So the probability of each one happening out of 6 trials is once. So if I do it 12 times, really I should have rolled each number twice, right? Did I roll each number twice? Did you guys roll every number twice? No. Some of them said they were close. That's good. They rolled some of them twice, but we are human. We're not perfect. So we're probably not going to get the theoretical probability if we try it on our own. Questions on the dice, or we feel okay? Okay, what we'll get into after break, because it's really confusing. Well, not really. Y'all just mess it up. Is the probabilities when you roll 2 dice. Because everybody always wants to put it out of 12. I'm just giving you a sneak peek. If you roll 2 dice, how many different outcomes could you have?
24.
What'd you say? 36. Extra credit, Jake. 36. Because there's 6 on this die, and then 6 more on this die. So let me just kind of explain it to you. You could roll a 1 on this one, and then a 1, 2, 3, 4, 5, 6. Then you could roll a 2 on the first one, and then a 1, 2, 3, 4, 5, 6. Then a 3 and a 1, 2, 3, 4, 5, 6. 4, 1, 2, 3, 4, 5, 6. So you really do 6 times 6 to figure out the number of outcomes. But we're not going to worry about 2 dice right now because that's not basic probability. That's compound probability. That's what we're doing after break. Okay? What'd you say? Yeah, Jake's ready. All right, so last set of probability experiments, and I'm going to pause. I'm going to do it with my people at home. You are going to get a deck of cards. You and your partner are going to take turns drawing from the deck. So this is the only thing I have to tell you. We're human, right? So we need to try to keep it the same each time. So every time before you draw, I want you to put the card back. I want you to shuffle. If you don't know how to shuffle, we'll work on it. I bridged. I told you I've been to Vegas. I've been twice. Won lots of money once, and I lost lots of money once. I'm going to do a bridge for my people at home so they can see how talented I am. Oh, word. Listen, you're getting a deck of cards. You and your partner, each going to take turns drawing, okay? After the first person draws, write down what you drew, like the exact card, so 10 of diamonds. Put it, you can draw it from wherever as long as you're doing it the same. So if we're just picking from the top each time, that's fine. Shuffle, pick from the top, shuffle, pick from the top, okay? Or you can spread them out, pick from anywhere in it each time, but do it the same each time so we can limit the amount of errors. Does that make sense? Any questions? You do put them back in the deck. What would happen if we didn't put them back in the deck? Good. What would get smaller and smaller? What part of the probability? If I'm not putting them back, not the
Drawing
total
a certain number / symbol.
Yeah, okay, good. So listen, you said the total number, you're right. So if I don't put it back, that's out of 51. Then I draw again, don't put it back, now it's only out of 50. Then I draw again, don't put it back, now it's only out of 49. If you're not putting it back, the total number of cards is going down, which means the denominator of the fraction goes down. So we are putting it back. Do we understand? That was a great question. Okay, my people at home, I'm going to be right back to draw cards with y'all. I'm going to pass out theirs. Once you finish, I hope we're listening because I'm not saying it twice. Once you finish, here are your 4 probabilities that you need to find from your experiment data, okay? I'm going to give y'all about 30-ish seconds with your cards and then like a minute with the probabilities. Seats face the front. If you're not done, that's okay. So my people at home and me, the probability that we drew a spade, wow, y'all, we drew lots of spades, was 4 out of 10. Which reduces to what? They're not listening, so I'm going to talk to y'all.
2 out of 5.
Good, Riley. 2/5. I'm ignoring y'all because y'all are being annoying today. Did I ask? Don't make me be rude. How many face cards, whoever said face cards, I think it was Riley. How many face cards, my people, did we draw?
2.
Good. Okay, do we all know what a face card is? The ones with the faces. Does an ace have a face? No. An ace is a letter. That is not a face card. So I'm talking about kings, jacks, or queens. Me and my people drew 2 kings. That was it. So 2 out of 10, which reduces to 1/5. And then probability of a red card, my people. How many red cards did we draw?
4.
Yeah, 4 out of 10 because we had 4 total diamonds and hearts, 2 of each. That was pretty good. So 2/5 again. And then what was the probability that we got if we drew a card less than 4?
2 to 3. Depending on how you look at it.
Okay, I like what you said. I hope the people in class are listening, but I don't think they are. That's okay. I'm just making sure you're listening. I can't tell what Chris doing messing with his sneakers. I hope you listening. The probability that we draw a card less than 4, you're looking at all 10 outcomes, all 10 trials. How many times did I draw a card that was less than 4?
2 to 3.
Good. 2 or 3 is what Carter said. Depends on how you look at it. You always assume that ace is high unless I tell you it's low. Does that make sense? So less than 4, we're going to say 2 out of 10, which is 1/5. Now, I want y'all to look in class. Did I draw the same card more than once? No. Is that a good thing or a bad thing? Okay, in Vegas, it would be bad. In an experiment, it's good. Why is it good? How many times should I theoretically draw each card? Once, because there's 52. So if I did this more than 52 times, then it would make sense if I drew one more than once, right? But that means that I ran a pretty good experiment being human if I drew each card only once. Do we agree? I already said that. You assume they're high unless you are told the ace counts low. Good question. You assume it's high unless you're told it's low. Or y'all feel like you can find card probabilities?
Yes, ma'am.
All right, so we got a couple of notes to take, very short, and then I'm going to turn y'all loose on your classwork homework, which should probably take you like 10 minutes. I promise. It's short. Like, it's a worksheet, and it's got a spinner and some dice on it, and it asks you for probabilities, and then the back talks more about cards. So for your notes today, quick notes, we're going to write down some definitions, and then I feel like y'all are good, honestly. I don't think we need to do any examples because we just did a bunch in the experiments. Are y'all okay with that? Okay. So what is probability? If you had to define it, if somebody asked you what it was, what would you say? Okay, I'm gonna go off of what he said because I like it. He said the chance of rolling, flipping, or drawing something. So the chance that an event happens, right? The likelihood of something happening. So I'm gonna write that. The chance / likelihood of an event happening. So then that leads us right into our next one. What do I mean when I say the word event? Because I said it in the probability definition. So what did you say a second ago? Yeah, so he said like drawing, flipping, rolling. Those are all events dealing with like cards, dice, or coins. So an event is just something that we can measure the outcome of, basically. Something we can measure the outcome of. So just to make sure y'all have this down in a spot as well, what are the 4 ways to express probability? Okay, I like that. A fraction. Now let's talk about the fraction really quick. The fraction should always be between what 2 numbers? Okay, good. What did you say, Sean? 0 and 1. Why is it 0 and 1? Anybody want to help them out? Think about cards. If it's out of 52, are you going to be able to have 53 times of it happening? No, 53 over 52 would be bigger than 1. If it happens perfectly, it's going to be 52 out of 52, which is just 1. If it doesn't happen at all, it would be 0 out of 52, which is 0. So it should never be bigger than 1 or less than 0. It should always be in between those. What's another way we can express probability? Okay, with the 2 dots. Yeah, okay, good. So a ratio, now ratios are done the exact same way as a fraction. So we can really just say fraction or ratio with the 2 dots. What did you say, Viti?
Decimal.
Decimal. So Vidi, what should the decimal be in between? I'm gonna put it down here.
0 and 1.
Very good. Still in between 0 and 1. So for example, if it said, what's the probability that a card is black? What would that be? Ooh, how many black cards are in a deck?
0.5.
26 out of 52, which is what, Carter?
0.5.
0.5 or 50%. So 0.5 is in between 0 and 1. Very good. So then the last way Jaden just said it is a percentage. What should your percentages be between? Very good, Henry. 0% to 100%. 0% is the chance that it never happens. 100% is the chance that it happens every time. Very good. So then the last thing we need to write down, are y'all okay with that? Am I going too fast? You're good. I feel like this is review. I just want to make sure we're all on the same page. So then the last thing I want us to talk about is our probability formula. This is just the basic one. You are going to learn more formulas after break, but I saved all the hard stuff for after spring break, so you'll be refreshed. So the probability that an event will happen equals what? What did we do each time to find our probabilities? We've already said it. Let's see who was listening. On the front, when we did our experiments, how did you find each probability? How many times it happened over what, Evan? However many times you did it. All right, so let's talk about that. So it's the chance that occurs over the total number of outcomes. I like that word Jaden used, so I'm gonna use that too. So anytime you're finding a probability, even if you want it as a percent or decimal, you still do that by doing the chance that occurs over the total number of outcomes. Does that make sense? So while you're finishing, I just want to show my people at home the homework, very short. There's a spinner, asks you about probabilities off of the spinner. There's a dice that asks you about probabilities off of a dice. And then there's like some shapes and it asks you for probabilities from those. Then the back is just, it looks like a lot. I'm telling you, it should take you 10 minutes. The back is talking about cards. And then there is a challenge problem at the bottom, but I think y'all will be fine with that too. Okay? Any questions for me? Yes, you have to do the challenge problem. When I say challenge problem, I mean you're doing it.